Imagine, you wake up one morning and every news channel on Earth is saying the same thing. A massive asteroid is heading toward our planet. No superheroes, no secret alien technology. Just us humanity and a ticking cosmic clock. Sounds like a sci-fi movie, right? But here's the twist. This is not fiction. This is real science. And NASA already tested a planetary defense system in space. Yes, we actually tried to change the path of an asteroid. Let's talk about NASA's real plan to stop asteroids. The DART mission. For billions of years, asteroids have been the silent killers of the universe. Around 66 million years ago, one giant space rock wiped out the dinosaurs. That impact changed Earth forever. It wasn't dramatic background music. It wasn't slow motion. It was instant devastation. So the real question is, if another asteroid comes for us, are we ready? In the early 2000s, scientists began tracking near-Earth objects. Asteroids and comets that pass close to our planet. Most of them are harmless, but some are large enough to destroy entire cities. NASA knew something important. Waiting until the last minute is not a strategy. That's where DART comes in. DART stands for Double Asteroid Redirection Test, launched by NASA in November 2021 aboard a SpaceX Falcon 9 rocket. This spacecraft wasn't going to study an asteroid. It was going to crash into one. Yes, on purpose. The target was not a planet killer. It was a safe test system. A binary asteroid system called Didymos, and its smaller moonlet, Dimorphos. Didymos itself is about 780 meters wide. Dimorphos, the smaller one, is about 160 meters across, roughly the size of a large stadium. These asteroids were never a threat to Earth. That's important. This mission wasn't about panic. It was about preparation. The idea was simple in theory, but terrifying in execution. Hit Dimorphos at extremely high speed and slightly change its orbit around Didymos. Just a tiny nudge, a small shift in its path. Because in space, even a small change, applied early, can mean the difference between a miss and total annihilation. On September 26, 2022, after traveling for 10 months through deep space, DART approached its target at about 20,500 kilometers per hour. No remote control joystick. No last-second steering by astronauts. DART used an autonomous navigation system called SmartNav. It locked onto Dimorphos and adjusted its path in real time. As it got closer, the images became clearer. A rocky, uneven surface. A silent, ancient object floating in the darkness for billions of years. Then, impact. At 7:14 p.m. Eastern Time, DART smashed directly into Dimorphos. The live feed cut out instantly. Silence. Scientists around the world held their breath. Did it work? Or did we just throw a spacecraft into space for nothing? Here's where it gets intense. Before impact, Dimorphos orbited Didymos every 11 hours and 55 minutes. After impact, astronomers measured its new orbit using telescopes on Earth and in space. The result? The orbit changed by 32 minutes. Not seconds, minutes! That's 25 times more than the minimum success criteria. Humanity had just altered the motion of a celestial body. For the first time in history, we moved an asteroid. But here's the deeper truth. DART was not about destroying asteroids. It was about deflection. Because if we detect a dangerous asteroid years or decades before impact, we don't need explosions. We don't need nuclear weapons. We just need a gentle push. Imagine an asteroid heading toward Earth in 20 years. If we nudge it slightly today, that tiny change multiplies over time. By the time it reaches Earth's orbit, it misses completely. It's cosmic billiards. But this mission also revealed something unexpected. When DART hit Dimorphos, it didn't just create a small dent. It released a massive plume of debris. Far more than scientists predicted. This extra material acted like a rocket exhaust, amplifying the push. In other words, the asteroid's own material helped move it even more. That was a shock. It means future missions must carefully understand asteroid composition. Are they solid rock? Loose rubble piles? Metallic cores? Each type will react differently to impact. This is where international collaboration becomes critical. After DART's success, the European Space Agency prepared the Hera mission, which will visit the Didymos system to study the crater left behind and gather detailed measurements. Hera will help scientists understand exactly how the impact transferred momentum. Because stopping an asteroid isn't about luck, it's about physics. And here's something even more important. NASA continuously monitors the sky through programs like the Planetary Defense Coordination Office. They track thousands of near-Earth objects. As of today, no known large asteroid poses an imminent threat to Earth. But no current threat does not mean no future threat. Space is unpredictable. New objects are discovered every year. So what happens if we find a truly dangerous asteroid? One large enough to destroy a continent? There are several theoretical methods beyond kinetic impact, like DART. One idea is a gravity tractor, a spacecraft that flies near an asteroid and uses its own gravity to slowly pull the asteroid off course over time. Another concept involves nuclear devices, not to blow the asteroid into pieces, but to detonate near its surface and create a forceful push through vaporized material. But nuclear options are controversial, risky, politically sensitive. DART proves something powerful. We might not need extreme measures. We can defend our planet using precision, science, and timing. But here's the twist no one talks about. DART worked because we had years of preparation and a cooperative global effort. If a large asteroid were discovered only months before impact, our options would shrink dramatically. Planetary defense is a race against time, and time is something the universe does not negotiate with. Think about it. For billions of years, Earth has been a target in a cosmic shooting gallery. Impacts shaped our oceans, our continents, even life itself. But for the first time ever, a species on this planet is aware of the threat and capable of doing something about it. That changes everything. We are no longer passive observers in the universe. We are participants. The DART mission wasn't just a spacecraft colliding with a rock. It was a message that humanity is growing up on a cosmic scale. We are learning how to protect our world. But here's the final shock. The most dangerous asteroids are not always the biggest ones. A 100-meter asteroid hitting a populated area could wipe out an entire city. The 2013 Chelyabinsk meteor in Russia was only about 20 meters wide, and it still injured over 1,000 people due to the shockwave. Now imagine something 5 times larger. We don't need a dinosaur killer to face catastrophe. That's why missions like DART are just the beginning. In the coming decades, planetary defense could become as important as climate science, cybersecurity, or global health. Because the next big test might not be a simulation. It might be real. And when that day comes, the question won't be, can we stop it? The question will be, did we prepare in time? NASA's DART mission proved that changing the course of an asteroid is possible. It proved that science fiction can become science fact. And it proved that Earth is not defenseless. But the universe is vast, silent, patient. Somewhere out there, another asteroid is already traveling through space. We just haven't seen it yet. This is not fear. This is awareness. Because for the first time in history, humanity has the power to slightly move a mountain in space and save an entire planet. And you're living in the generation that witnessed the moment we learned how to defend Earth. You're watching Infinite Cosmos.